In this video, we'll be looking at summation notation one more time. This, however, we're going to go ahead and try and build the summation notation of the sigma variation of the sum that we're actually working with. Now, in this particular case, you're going to have to look very carefully and do your best to try and find a pattern. What I notice here is that this is 1, 4, 9, 16, 25, 36, and that each of these numbers is nothing more than something squared. If that's the case, this is actually 1 squared. This is 2 squared, 3 squared, 4 squared, 5 squared, and 6 squared. Knowing that that's the case, I can very quickly see that I'm going to have 6 terms, so I need a summation such that I start at some number that you choose to start at. Now I'm going to start at the easiest value to choose. That's this one right here. So I'm going to start at 1, and it's very clear that I'm going to plug in 1 up until I get into 6. So I plug in 1, then 2, then 3, then 4, then 5, then 6, which is exactly how summation notation is supposed to work. But what's the function on that term? Well, it's nothing more than I squared. So you'll notice very carefully that that is the formula that we're working with in this example. In this example down below, you'll notice that all these terms are actually in terms odd. You'll also notice that they alternate positive, negative. So there's actually 2 different things here that are happening. And again, that's the way I want you to visualize these things, is what are the pieces that are changing? Well, from here to here, you'll notice that it's still an odd term every single time, but it's the next odd term. Now, odd terms generally have a formula either 2n plus 1 or 2n minus 1. And to be honest, you can actually just continue to add or subtract 3 from this term right here, and it'll still be considered an odd value. So it's actually going to be this one, or it's going to be this one. Again, it entirely depends on what you want to start with and where you want to start at. So I know it's going to be a summation of n equals something to something with some form of 2n plus 1, or 2n minus 1. Again, it entirely depends on where I start. If I want to try and use 2n plus 1, I'm going to go ahead and write that in there, 2n plus 1. Then it means that for me to get back 3 for my first term, my first starting n value has to be 1. Now again, be very careful. This is nothing more than a guess and check. If I plug in 1 for the n, I get 2 times 1 plus 1 is 3, and that gives me back the 3 that I want. So if I pick 2n plus 1, I want to start at 1. Now, the second detail I need to figure out is where am I going to stop? Well, if this is term 1, then this should be term 2, 3, 4, 5, 6, and 7. So I should go from n equals 1 to n equals 7. Now again, if you don't trust that, by all means, plug in 7 for your last term. 2 times 7 is 14, 14 plus 1 is 15, and that does give me that last piece. The problem, however, is the fact that it cycles from positive to negative, from positive to negative. Now, that's actually very simple for us to fix. If it changes signs, all you really need to do is have a negative 1 to the power of n, or a negative 1 to the power of n plus 1 or minus 1, or just some addition or subtraction of a 1. The reason why this will work is because if I try and plug in 1 to this will give me back a negative 1. But if I try and plug in 2, it's not positive. The same goes for this, but it's alternated. It starts at a different value. If I plug in 1, it now starts as a positive 1. But if I plug in 2, it goes to a negative value. So I need to take this odd term right here, and I need to multiply it by a negative 1 to some form of power of n. Well, let's start with it being just n. If I choose it to just be n to start, and I plug in 1, you'll notice that this is now going to be a negative 1 to the power of 1, which is negative 1, times 3. But my 3 is supposed to be positive. So that means that this n is not going to work. But if I do n plus 1, that means when I now plug in 1, I'm going to have 2 for this power, and that means that this whole thing is going to be positive. So it's going to be 3 times a positive 1, which is then a 3. If I try and plug in 2, that's going to give me back 5 here, multiplied by, when I plug in 2 here, I'm going to have negative 1 to the power of 3, which is negative. And therefore, 5 times a negative 1 is a negative 5. This summation, using guess and check, seems to provide us with this value, this list of terms. Okay? Again, there are other ways to answer this summation. This is not the only way. For instance, I could have considered starting at 0 and ending at 6. If I started at 0, you'll notice that this is down 1 and this is down 1. In here, this would actually change to be 2n. Instead of it, let me make sure that this is right. I subtract 1 in here, I add 1 in here, so 2n plus 3. And what's nice about the odd terms is the odd terms changes ever so slightly by just one value. So it'll be n, okay, or technically n plus 2, but that's not really going to change anything because this is just cycling the positives and negatives. So this is another way we could see this exact same formula, okay? Notice I started at 0 instead of 1, and this is changed to be 2n plus 3. Now in the last videos we talked about there being an addition and a subtraction of 1 occurring here. Keep in mind that the addition and subtraction is not really an addition to subtraction. I'm subtracting 1 on the outbound, the outside values, but in here what I'm really doing is I'm replacing the n that I have with an n plus 1. Again, I'm subtracting 1 in here, I'm subtracting 1 out here, but I'm adding 1 to the n that is here, which is why when I distribute this 2, I get 2n plus 3 up here. And again, which is why this n goes from n plus 1 to n plus 2, because again, the n changes to n plus 1, plus that extra 1 from outside. So again, this is not necessary, but it is a good skill to have once we get there. This is what we're looking for as a final answer. I will accept other notations that represent the exact same thing, but again, it must be written in sigma notation.